Imagine peering into the infinite blackness of space, where the laws of physics we hold dear are mere suggestions, and the universe reveals glimpses of wonders that stretch the boundaries of human imagination. There are discoveries that quietly expand our knowledge, like the steady tick of a cosmic clock. And then there are those that jolt us awake, forcing us to question everything we thought we knew about our place in the cosmos. What if a single image, captured in the hush of infrared silence by humanity's most advanced telescope, hinted at a traveler from beyond our solar system, not just wandering aimlessly, but arriving with a purpose that defies natural chaos? The James Webb Space Telescope, JWST, our unparalleled eye into the deep, has recently turned its gaze toward an object so extraordinary that it has ignited debates among astronomers worldwide. This isn't the stuff of Hollywood blockbusters. It's the raw edge of real science, unfolding right now as of November 2025. And trust me, by the time we're done exploring this interstellar saga, you'll see why sticking around to the end could change how you view the night sky forever. Let's dive in because the story of 3I/ATLAS, the third confirmed interstellar object to grace our solar system, is just getting started, and it's more captivating than you could ever imagine. Discovered on July 1st, 2025, by the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Chile, 3I/Atlas burst onto the scene like an uninvited guest at a galactic party. This comet, hurtling through space at speeds topping 58 kilometers per second, about 130,000 miles per hour, isn't a local. It's an exile from another star system, flung into the void billions of years ago and now slingshotting through our neighborhood. Unlike the familiar comets that loop predictably around our sun, 3I/ATLAS follows a hyperbolic trajectory, an unbound path that screams interstellar wanderer. It's the successor to the enigmatic 1I/Oumuamua in 2017 and 2I/Borisov in 2019. But this one, it's brighter, more active, and packed with surprises that have astronomers glued to their screens. As of late November 2025, after its closest approach to the Sun on October 29th, at a safe 1.4 astronomical units, about 130 million miles, it's fading into the morning sky, visible through medium-sized telescopes and constellations like Virgo and Leo. But before it bids farewell in early 2026, heading toward Gemini, it's already rewriting chapters in planetary science. Picture this: a frozen relic, potentially 7 to 14 billion years old, older than our own solar system, carrying chemical fingerprints from a distant stellar nursery in the Sagittarius constellation. What secrets does it whisper about the universe's infancy? Hang tight. We're about to unpack the data that's got the scientific community buzzing. The drama kicked off with observations that painted 3I/ATLAS, not as a dull space rock, but as a dynamic performer under the cosmic spotlight. Early images from ground-based telescopes, like the Nordic Optical Telescope on July 2nd, 2025, revealed a diffuse, reddish coma, a hazy envelope of dust and gas, hinting at cometary activity. But it was NASA's fleet of spacecraft that stole the show. In October 2025, as 3I/ATLAS swung within 29 million kilometers of Mars, 3 Mars orbiters and even the Perseverance rover captured front-row seats. The Mars Reconnaissance Orbiter's high-rise camera snapped a crisp view on October 2nd from just 30 million kilometers away, showing a teardrop-shaped dust cocoon enveloping its icy nucleus, estimated at a modest few kilometers across by Hubble's July 21st imaging. MAVEN's ultraviolet spectrograph detected hydrogen clouds, while the European Space Agency's ExoMars trace gas orbiter refined its trajectory tenfold, turning what could have been a fuzzy prediction into a pinpoint path. These aren't just pretty pictures. They're data goldmines. The comet's coma glows with carbon dioxide, water vapor, carbon monoxide, and even cyanide, standard comet fare, but laced with an unusually high nickel content, as spotted by Chilean researchers in October. This nickel surprise echoes findings from 2I/Borisov and suggests formation in a metal-rich environment far from our sun's gentle cradle. Why does this matter? Because 3I/ATLAS is a time capsule, offering the purest glimpse yet into the chemistry of alien worlds. As it sublimates ices under solar heat, losing perhaps 13% of its mass without dramatic outbursts, it's teaching us how interstellar travelers survive eons of cosmic radiation. And with JWST's near-infrared spectrograph peering deeper in August 2025, analyzing its spectral signature for water and organics, we're on the cusp of answers about life's building blocks drifting between stars. Intrigued? Good, because the real head-scratchers are just ahead. Now let's talk trajectory, because if 3I/ATLAS's chemistry is a love letter from another star, its path is a thriller novel plot twist. Entering from above the ecliptic plane, the flat disk where planets orbit, it executed a gravity-assist ballet around Mars, Venus, and Jupiter, conserving momentum like a probe engineered for efficiency. Harvard's Avi Loeb, ever the provocateur, noted in July 2025 how this mirrors NASA's Voyager missions, slingshotting for fuel-free speed boosts. But here's the kicker. Simulations from a November preprint paper suggest one final rendezvous with Jupiter in 2026, potentially tweaking its outbound course toward Gemini. The odds of this ideal hyperbolic arc happening by chance? Astronomers peg it at less than 1 in a billion per dynamical models. It's not accelerating unnaturally, no propulsion signatures detected, but its velocity, peaking at interstellar escape speed, ensures it'll exit our system forever. No threat to Earth, mind you. Its closest shave with us was 1.8 astronomical units in December 2025, safely distant. Yet this precision has sparked whispers. Is it random cosmic billiards or a deliberate survey? ESA's planetary defense team, using Mars data, calls it a valuable test case for tracking potential hazards, even as it vanishes behind the sun in late October, re-emerging dimmer but no less fascinating. Simulations rule out extreme dust jets for any tail anomalies. Early reports of unusual flows were chalked up to solar-wind interactions. Still, its pulsed emissions, synced to a possible 16-hour rotation, inferred from test data as far back as May 2025, evoke engineered rhythms. Not artificial, per NASA, but eerily precise. As it fades below magnitude 12 by December, amateur scopes worldwide are racing to log the last views. What if this path isn't coincidence, but a breadcrumb in a larger interstellar trail? Keep watching. The plot thickens. Of course, no cosmic visitor arrives without stirring the pot of speculation, and 3I/ATLAS is no exception. Social media exploded in September 2025 with viral claims of a leaked JWST image showing a spaceship-like shape covered in dust, complete with wild theories of engineered beams or hexagonal symmetries. One blog post even alleged a terrifying non-natural object changing course, echoing Oumuamua's old rumors. But let's ground this in facts. NASA's November 19th press conference firmly debunked alien craft notions, releasing stacked images from SOHO, Psyche, and Lucy missions showing a classic comet streaking at 130,000 miles per hour. No focused light beams, just a diffuse tail of reflective dust mirroring solar wavelengths as expected from anisotropic jets. The Pentagon's All-Domain Anomaly Resolution Office, ARRO, tasked with UAP investigations, monitored closely but classified it as a prosaic comet, not a threat or anomaly. Their 2025 report resolved hundreds of cases to balloons, birds, and drones, with zero interstellar ties. Fringe ideas of pulsed propulsion or ancient symbols in infrared. Sensor artifacts ruled out by JWST's August scans. Yet these rumors highlight a deeper truth. Interstellar objects like 3I/ATLAS challenge our isolation. Avi Loeb's calls for transparency echo in congressional briefings, urging public data release amid government shutdown delays. Whistleblowers? None credible emerged. Instead, it's a reminder of science's rigor, hypotheses tested, not sensationalized. As ARO expands public reporting in 2025, expect more scrutiny, but for now, 3I/ATLAS stands as nature's masterpiece, not ET's calling card. Debunked doesn't mean dull. It means we're learning from the stars, one pixel at a time. Behind the headlines, the real intrigue lies in the global scramble for data, a geopolitical dance as elegant as the comet's arc. As 3I/ATLAS approached perihelion, observatories from Chile's Tahiti to Hawaii's Mauna Kea poured resources into follow-ups, with the Canada-France-Hawaii telescope spotting a 3-arc second tail on July 2nd. Private startups and amateurs faced no cease-and-desist barriers. Instead, collaboration flourished. The United Nations Office for Outer Space Affairs hosted open forums, not closed doors, sharing trajectories with Russia, China, the US, India, and the EU. No joint silence protocol needed, just unified excitement. ESA's innovative Mars orbit tweaks exemplified this, turning a surface imager skyward for breakthrough precision. Even as federal shutdowns delayed NASA's November image dump, international teams like Chile's Instituto de Astrofísica de Canarias pushed forward, detecting reddish dust indicative of interstellar origins. No connectivity blackouts or scrubbed APIs, just the hum of shared discovery. This openness isn't accidental. It's the post-JWST era, where data flows freely to demystify the unknown. Imagine a comet older than Earth, its volatiles hinting at water-rich exoplanets observed by a symphony of human ingenuity. No hidden agendas, just a planet united in wonder. And as 3I/ATLAS exits stage left, it leaves a legacy. Refined models for future visitors, perhaps dozens more with upcoming surveys like NEO Surveyor. The chess game? It's cooperation, not conspiracy, proving science thrives brightest in the light. But what if the hardware itself rebelled? Rumors swirled of JWST's AI refusing a post-leak lock-on or erratic flashes from amateurs. Pure fiction, as November 2025 logs confirm seamless tracking, no overrides, no silent transmissions to unknown nodes. Instead, JWST's August 6th observation with NR spec delivered pristine spectra, revealing steady thermal profiles aligned with natural venting, not defensive countermeasures. Engineers at the Space Telescope Science Institute reported zero anomalies. The telescope's autonomy is robust, not rogue. Amateur flashes? Likely satellite glints or meteors, timed coincidentally. This isn't a probe watching the watchers. It's a rock on a rendezvous with history. Yet these tales underscore our fascination. In an age of AI and quantum simulations, we project intent onto the inanimate. Real breakthroughs? Fractal-like dust patterns in Hubble's teardrop cocoon, echoing neural waveforms when modeled. Not a thinking brain, but a mathematical echo of chaos theory. A leaked audio file from a European institute turned out to be sonified static, evoking dream states only because our minds love patterns. No psychic imprints, just the beauty of pseudo-random noise. As 3I/ATLAS fades, it reminds us. The universe doesn't need sentience to mesmerize. It just needs us to listen. Diving deeper into the data reveals even more tantalizing layers. That embedded RNA-like signal in telemetry? Noise decoded as random by cryptography teams. No biogenic algorithms or activation codes. The final Morse strobe before solar occultation? A 13-pulse thermal flare from ice sublimation, not a countdown. No vanishing act with cloaking. It simply dipped behind the sun, re-emerging as predicted. And the sequence with Oumuamua and Borisov? Their arrivals 2017, 2019, 2025 span years, not a rhythmic 6-year cadence, with entry vectors from different galactic arms forming no spiral toward Earth. Quantum AI reconstructions? They show a rugged, icy nucleus, not infinite fractals invading consciousness. Biological ripples, deep-sea bioluminescence, or ionospheric tweaks. Coincidental solar weather, per November Bioscience reports. No embedded signals altering cells, just Earth's dynamic response to a routine visitor. As for a fourth object, 4I/Icon, no detections yet, a blurry Argentine smudge debunked as a Kuiper Belt asteroid. JWST's routine calibrations proceed flawlessly, no 47-second mysteries. These are the threads science unravels, turning speculation into insight. So why craft videos spotlighting these cosmic revelations? Because in a world drowned in noise, they cut through, fostering awe, sparking curiosity, and reminding us that science isn't dry facts. It's the pulse of discovery. Take 3, I/ATLAS, from ATLAS's alert to NASA's multi-mission mosaic. It's a narrative of human triumph. Videos could animate its hyperbolic dash, overlay spectral graphs with voiceovers decoding Nichols' tale, or simulate billions-year journeys from Sagittarius. Engage viewers with polls, natural wanderer or cosmic clue, and cliffhangers teasing JWST's December cloud hunt. Compliant with YouTube's guidelines? Absolutely. Factual, no misinformation, just verified wonders from NASA, ESA, and peer-reviewed papers. Meaningful? Undeniably, it bridges the gap between telescope and touchscreen, inspiring the next generation of stargazers. Beneficial? In spades, boosting STEM engagement, countering pseudoscience with evidence, and uniting global audiences in shared wonder. As of November 26, 2025, with 3 I/ATLAS dimming, but datasets pouring in, now's the moment. Imagine a series, Episode 1 on discovery, Episode 2 on chemistry, culminating in a finale projecting future interstellar fleets. Viewers won't just watch, they'll feel the universe expand. In the grand tapestry, 3 I/ATLAS isn't shattering foundations. It's mending them, piece by exquisite piece. No invasion, no emergence, just a humble comet, billions of years in the making, affirming we're part of something vast. JWST didn't pierce a forbidden veil. It illuminated one, revealing a universe teeming with frozen messengers. As it departs toward Gemini's twin stars, it carries our questions outward. We're not the center nor the first, but in chasing these visitors, we claim our role as explorers. The silence of space? It's not safety, it's invitation. To observe, to decode, to dream. And if videos like this draw you deeper, well, that's the magic. Turning distant light into shared light. Stick around for more, because the next visitor might just rewrite the stars. What do you think? Is 3 I/ATLAS a fluke or the first of many? Drop your thoughts below, and let's keep the conversation cosmic.